Hello everyone, welcome back. Today we're gonna study about what are Python sets, how they are created, adding or removing elements from them, and also all the operation performed on the sets in Python. I hope the previous that list strings and moreover your data types is clear to you and open to the tuples. Now today we're gonna study about what are Python sets. The next one would be the dictionary. Now, what is the Python set? What is a set actually? A set is an unordered collection of your items. Every element is a unique and must be immutable. However, we know the set is itself is immutable, but we can add, we can remove from it. Set can also be performed through a different like mathematical set operations like union, like intersection, your symmetric or difference in that. Now, how is a set created? Now, what are the basic numerations of creating a set? A set is always created by placing all the elements inside a curly braces. Remember one thing, that curly braces are used and they are being separated by the commas or by using a built-in set function. Now in this, the elements we have the integer, we have float, we have tuples, we have string. But a set cannot have a mutable elements like list or dictionaries. It cannot have a mutable elements in it. However, we know it has a particularly a basic thing to remember about once a set is going to be studied about. Now, what we studied about what is your set and how your set is created as. Now, I told you that a set is a unordered collection. Just remember one thing, that what is your set? It is your unordered collection. First of all, it is your unordered collection. Second one is that everything is unique. This is of your set. Give me a minute. For whom we are talking about, this is of your sets. This is of your sets in Python. And third point, we remembered that it is immutable. That it must be every set is unique and must be immutable. Correct? And itself we know that element should be immutable, but set is itself is immutable. And for creating a set, we used to place the elements in your curly braces. Remember this thing, we have to create we have to place all the elements in your curly braces. If we know in list we use the brackets, that is square brackets, and for placing the in tuples we use this circular brackets. But in tuples, you know that it is not compulsory to place elements in your parentheses, but still we use that to look at nice. Now what happens is, like whenever we used to create any of your set in your particular oftenly in your dictionaries on your list, it knows that we cannot like have a mutable elements like list or tuples or your dictionaries, but still it can be used. And how it is used, I'll show you. First of all, for creating any of your set, you have to declare it. Now if I'll declare some value like it is 5, then 7, sorry, it is 5 comma 7, okay, 5 comma 6 comma 7, okay, it has been created. Now if I'll print this set, so outcome would be the same. What if we have a mixed data type? Let us perform that example. Now let us perform an example of which it has the various types of data types. Okay, let us like first of all declare a set. My set, and this set is to be placed in your curly brackets. I'm giving an example of 1 comma 2 comma 3. Okay, then let's print this set. Print what? My set. Correct? Let us run this. The outcome is 1 comma 2 comma 3 in your parentheses of your curly braces. Okay, now what it if it has the mixed types of data type. What it has the mixed data types. Correct? I'll place, I'm placing this 1 comma 0. Okay, then I'll placing a string, that is any hello. Got it? Then I'm getting it some of the list, some of the tuples. Okay, correct. Now when I'll print my set again, the outcome is all. So this means that what happens is your set can take any of your data type, correct? But it can only and only take, a set cannot have a mutable elements like list, sets or dictionaries. We cannot have a set, list or dictionaries. Okay, correct. But if it has a duplicacies in that, what if you have a duplicacies and started often to the more of the power in it, correct? But this is also the oftenly used part where we can use some of the dictionaries and the part we can use mixed data types. Okay, mixed data types we can use, correct? And oftenly we cannot use list, we cannot use sets, we cannot use dictionaries, correct? We cannot use that. Now moving forward to creating a empty set or the set containing some information in that. If I'll say the printing the simple output like my set is equals to this, we cannot get any items. But when I'll say that I'm creating a set, but that set has a numerous value, that is actually the point to be grabbing up. So list and tuple, how they are being different. So list can append, tuple cannot. It only added. List can extend, it cannot update. Okay, the tuple can update. List can insert, tuple no we cannot. And pop and remove, these are the method types. And tuples we have remove and discard tuples data type. Correct? Now how is your adding of your element to a set? Why is your adding of your element in your set is needed and how we can add the following sentences in that. Now moving forward to your adding up. Your sets are mutable, but since they are unordered and indexing have no meaning, we cannot access or change the more often the type of it. And regarding the type and your standardization, we cannot access or change the elements of set using any of indexing or analyzing. Slicing. Just remember this point about the indexing and your slicing. We can add the single element using the add method. This is a method type. Okay, add is a method type, and for the multiple elements we want to add it is your update. Any of your update method can take tuples, list, string, or any of your sets as they are being argumented. In all the cases, duplicates are allowed and avoided, not to be used oftenly. Not to allowed, it cannot use. It has to be avoided somehow. Correct? Now what we will make sure like are some of the programs are running properly, because and more often we need to have an that the type also to remember. Okay, type also to remember, like if I'll say my a is equals to null, say my A is equals to null, correct? Then I'll print the type. Print type of whom I have to print, it is A, correct? When I'll get to this, it will give me the error. It will not give me the error. It is the type. Type is your dictionary. Okay, it is distinguishing between sets and dictionary. How your set is distinguished and how your set is not. Now when I write the set of whom, it will give me the class set, correct? This is according to your initialization of your set in your type formation. Now coming forward to your removing, like how to modify, how to remove, how to formulate the difference between discard and remove. Okay, now in your removing element from the set, a particular item can be removed by using a set, and that set method is known as a discard and remove. Okay, both are used as in discard and remove, but using a discard, the item does not exist in your set, it remains unchanged. But remove will, in your discard, it means that it doesn't exist in the set but it remains your unchanged. But remove means like it will raise an array in such a direction or the condition that it is not shown open. Now what happens is your adding and removing. Adding, we used to simply get your add method and update method. In removing, we simply get your remove and your discard method. Okay, that is oftenly used with a particular set. Let's move to one program. We'll perform this program with both discard and remove. Okay, both discard and remove while using. So let us create one set. I'm just taking simple numbers. 1, 2, 3, 4, 5. Correct? Now I'm printing my set. Now look the output. How my output would be looking. If I'm doing simple print my set, the outcome is 1, 2, 3, 4, 5. Okay. Now what if I'll discard? Correct? If I'll write print, or my discard, I can do it. Okay, let's add one line in line number 2 or 3. Correct? I'll write that my set discard. Discard what? Position we can write as in 4. Okay, if I now want to print the 4 I need to discard, the 4 is remove. Okay, that's how the discard is used. Similarly, if I'll write discard discard 2, correct, the discard 2 will be removed from this elements. Correct? Now what if I'll, instead of discard, if I'll say remove, I have done the remove and run this at the second position. So happening is same. Removing, not presenting in my set, or error or type error, it is just the same part about that. But the condition forms here is, just read again, like using discard, if the item does not exist in the set, it remains unchanged, but remove will raise an error in such a condition. Okay, if I write remove 7, if I'll say the remove, it is giving the error. But what if I'll write the discard over here? Discard, nothing will happen, but to remove, it will give a type error. That's it. That's it. Is your basic formulation, I can say, or basic differentiation it has to be. Okay, now modifying a set, how we can modify a set with a various conditions. Okay, As we know that the sets are mutable, and since they are unordered also, and indexing has no meaning, we cannot access or change an element of a set using indexing or slicing. Such data type does not support in it. Okay, we can add a single element using add method or multiple elements to update. Correct. Similarly to the remove, we have the discard and remove. In your adding, we have your in your like modifying, we have add and update. Correct. Now the add and update, the update method can take tuples, list, and strings, or other. In all cases, it will duplicate it out. Correct. If I'll just like I don't want to remove this. If I'm doing this only, add and update. Let us comment add and update. Correct. If I'll write the print again, print my set, run it out. The set is print. Okay. If I'll write that print my set, but that my set add would be add at the position 2. Okay. So the answer will be, the outcome would be the same. No, I'll add my set add 2 is already there. No? We can add 6. So the output is 1 comma 2 comma 3 comma 4 comma 5 comma 6. The 6 is added. Similarly, if I'll write 9 6 comma, let us check like if it takes it or not. If I'll write 6 comma 9, no, it will not take double. Okay. So this how we can add, but we can update if we need a multiple. This is for a single. If we need to have a multiple, we have to write here update. Similarly, I was doing for the 6 and 9. Okay, update करना है मुझको हम करते हैं अपडेट 1 comma, no, 1 is already there, 6 comma 7 comma 8 comma 9 comma 10. Okay, now let's print it. So outcome is up to 10. 1 comma 2 3 4 5 6 7 8 9 10. In add, only one element it was taking. In update, the multiple it can take out. Okay, in the multiple part we can give out or take out. But adding a list and a tuple, I'll show you. This is just a list. Okay, but what if we have to add list and tuple both? Okay, now let me just divide this out. Up to this, let's keep it as list. Okay, and moreover, this we can take as a set. Okay, now let us print it out. So the outcome is same. We have done what we have done. One we took a list, one we took a set. Okay, the adding of your list and set is given out as in my set, and printing of it. Removing is done, modification is done, adding is done. Now moving forward to a concept of the membership test. We can test if the item exists in the set or not, but we have to use your in operator in it. Okay, what is in operator, how we can use an in operator, that is completely different, but these all are given as a memorable part of your set which has to be difference in it. Okay, now moving for a very good example and very good one of your modification in it. It is your set operations. But before that, I'll make you clear about some of the operations in it. Okay. Now the set can be used to carry out any mathematical set operation like union, intersection, difference, symmetric difference, or we can do with your operator method also. Okay. Now what is union? What is intersection? What is difference? What is symmetric difference? That we all are going to study about. So let me open this again. Okay. Now, as I already told you, set are used to carry out. Just a minute. As I already told you that the sets are can be used to carry out a mathematical operation like union, differences. Then we can see out more of your interaction differences. Okay, so similarly to this, it has to be used as a functionable part. We can consider two sets oftenly we use it. Okay, give me a minute. Mm, let me just make a shape. So we are making two of your shapes in that. I'm explaining the union. Okay. Um, Again, we'll take one more shape. Correct. This is I'm gonna some I like small and bigger circles are made. Okay. Still we can you just see what it is. This is for union. This is the union set. Now, moving forward to the union set. What is your union set? This is A union. This is B union. Union of A and B is all set two elements, okay, from both of the set. Union is always performed by using this operator, line operator. Okay, I think it is not looking good. It is always being performed with this operator. This is a simple line. And same can be accomplished by using, like, if you don't want to use this sign, you can always write the union of A and B. Okay, we can say that the union of A and B. This is just an union set. Okay, moreover, we're gonna read about your union interaction, intersection. But before that, let's perform one of the example of your union set. Now, it is completely different, just you need to understand. I'm just taking one example of union set. I'm taking A set. Let us take small one. Okay, A comma B. Okay, and the B set is 6 comma 7 comma 8 comma 9 comma 10. Okay, now I need a output of these both union operators sets. Okay, now what I'll write print A, okay, to the B. Okay, I'll write A to the B. So let us run this. So the outcome is all. Union means like ए के भी एलिमेंट्स और बी के भी एलिमेंट्स. यूनियन मीन्स कि सभी एलिमेंट्स एक ही आउटपुट देंगे. सो एक आउटपुट देने को कहाँ पर आ जाएगा, ए भी आएगा और बी भी आएगा इसमें. ठीक है, तो ये है अपना क्या कहते हैं सेट यूनियन इन अ मेथड ऑफ, एंड यूनियन इन ऑलवेज रिप्रेजेंटेड बाय द यू. ओके, just remember one thing, that the union is always being represented by you. Interaction, it is your the starting point. Okay, now what happen if we take the example of intersection, sorry, it will give us set intersection. Correct. Set intersection is what? Again, I'll make two circles. This is circle 1, it can be replicate also, no? Correct. We can. This is circle 2. Correct? This is circle 1 and this is circle 2. Give me a minute, yeah. And in your circle 1 and circle 2, the space, this is set A. This is your set A and this is your set B. And this is completely filled with your color. Okay, I'm just doing it. I'm just shaping this part. This is completely filled with your the part of your intersection, means like common path. So intersection of A, intersection of B is a set of the elements that are common in both. So these are common. This space is common. This is set A, this is set A, and this is set B. And this space is common. So we called it as an intersection path. Intersection is always performed by AND operator. That was performed by this operator, and this is performed by AND operator. This is the AND operator. Correct? And it can be same accomplished by using intersection. Here we used to write the union, and here we can use as an intersection. Sorry if my spellings are wrong. Intersection this. Okay? And it is wrought by I. It is wrought by this part. Okay? Intersection is wrought by this as well as with the common section. Now what are the examples of intersection and how it is presented? We'll take the same example, but we will make something common in this. We will make common 4, 5, 6. And instead of this icon operator, we will use the AND. Let us run this. So the outcome is 4, 5. We have, this is your intersection. Let us rename this. Okay, it is intersection set. We have 1, 2, 3, 4, 5 in set A. And in set B, we have 4, 5, 6, 7, 8, 9, 10. 4, 5 is also there and 4, 5 is also there. It is common in both both the set. So the outcome is your 4, 5. Okay. What the outcome is? It is 4, 5. What if this interaction is happened by using the concentration part of your function? The outcome would be still the same, but the sum of the differences would be there. Now coming forward to we have read the union, we have read the intersection. Now we will be moving forward to your differences. Okay. Now what are the differences? It is known as set differences. Give me a minute. It is known as set differences. Correct? Now what are set differences? Again we will make 2 of your circles. Again we will make 1 more circle. Okay, now this is set A. This is your set A. And this is your set B. Okay, now the set difference, what is set difference? The difference of your set B from a set A minus B is a set element that are only and only in A but not in B. Okay, let me shade this little bit. This is your set A. Okay, now what it is, the difference of the set B, the difference of set B from whom? From set A, and set A is A minus B. It is your A minus B. Okay, is a set element that are only in B. Okay, is a set element that is only in that are only in A. Correct? Remember this. But it will not appear in your B. Not in B. It is your difference. Correct? Similarly, opposite to the B. This is for A, and similarly it will opposite to the B. Means like B minus A is a set element in B but not in A. Okay? The difference is always performed by, the difference is always performed by the minus operator. This operator we use a lot of time. The minus operator. Okay, it is also accomplished by difference and this. Okay, it is always accomplished by, and this is known as a method. Okay, in this we used to as a method. Correct. Now let us perform one more example in this. Let's keep the same set, but this is your difference. We'll keep the same. Now we have to minus it out. Okay, that is the difference operator. Now check the output. The output is 1, 2, 3. This is the operator we have been using from A. Just read this line again. The difference of set B from set A. A minus B is a set element that are only in A but not in B. Only in A but not in B. Correct? So outcome is 1, 2, 3. B में तो है ये 4 और 5 भी है ना, इसमें तो है नहीं. बट अगर हम फिर से अगर देखें B माइनस A करते हैं, अगर इसको हम रन करते हैं तो आउटकम होगी 867 वी हैव इन बी, और 4 5 तो हमारे पास ऑलरेडी है उसमें ए में, तो हमें तो वो लेने की जरूरत नहीं ना 4 एंड 5, तो हमें के 6 7 8 ही हमें चाहिए. And these are the outcomes we shall use to perform it out. Okay. The last one is your the systematic difference. What is your systematic? What is your symmetric difference? Let us know about this. What is symmetric difference and how it is performed? It is again make two shapes. Correct? This is shape 1 and this is your shape 1 and this is your shape 2. Correct? I know this is little bit small. Okay, but these are the two of the set. Now these are the systematic. This is set A and this is set B. Correct? And your symmetric difference of your set, we have to color this both. I just need to leave the sum of your common part. Okay, we have colored this. Okay, now this part is left. This is A set, this is B set. This is the symmetric difference of A and B is a set of element A and B, but not in both, excluding the intersection. This is your intersection, and this is your set A and set B. Correct? This is your set A and set B. And symmetric difference is always performed by this operator. This is the operator used in this. It is always performed. In union we used this operator. In intersection we in intersection only intersection, symmetric and set difference. Yes, in this operator, in your set difference, in your set interaction we use this one. In your set difference we use the minus and minus A minus B from 2 or B minus A. Correct? In a set symmetric difference, we're gonna use this operator. Correct. Now same can be accomplished by using the symmetric difference, like we use in this. We can also use a symmetric underscore difference. Okay, and this one. Okay, these are the parts we can use. Now let us form one more example of the set symmetric. What it is? Give me a minute. Now when I'll use the same operator of your symmetric and write the same part, but if I'll write a symmetric difference of b, let us run this. So the outcome is 1, 2, 3, 6, 7, 8. Correct? Output is literally very good one. 1, 2, 3, 4, 5. There is 4, 5, 6, 7, 8 it is. What we said that what is intersection we will not include it. So 4 and 5 is also there and 4 and 5 is also here. So this will exclude rest. All the elements will be given as an output. Okay, these are the set of your operation we can perform with multiple operations. Correct? Your union is done, your intersection is done, difference is done, symmetric difference is done. Correct? Now, set mutation operation. So we have seen like the application of union, intersection, difference, symmetric difference operation, but these operations do not have any key value or the change or mutation to the set. But for this we use update, intersection update, difference update, symmetric difference update, and symmetric difference update. For like in your union we use this operator, intersection this, difference this one we use, and symmetric difference we use this operator. Instead of this, we all are going to use a equals to after it to create a mutation to a set, particular set. Okay. Now is coming is disjoint, is subset, is superset. This means is disjoint means like it. This method will return true if the true if the two of the value have a null intersection, like we did in your difference symmetric one. If this doesn't have any intersection or any of that, it will return as a true value. In its subset, it will report the whether this another set contains this set or not. In your S superset, superset will report whether this set can contain another set or not. Correct? These are the fumulations operations in it. Just remember one more thing. This is very much important to remember about. That union we use which operator? This operator. Intersection we use AND operator. Okay. Then in your difference, in difference we use minus. Symmetric, correct? In symmetric we use this operator. Just remember this. These are the main of the points to remember often to this. Okay, correct? I hope this much is clear to you. The literally points are, these are very small points that you have to remember while containing your sets. Now next we will study about what are the dictionaries, how to create a dictionary, what are the basic advantages over dictionary and list, and over the strings too. Okay, I hope this much is clear to you. Thank you so much for being there.